If you've ever opened a solution and instantly felt overwhelmed by the web of files, references, and bugs waiting to ambush you, you're not alone. Most developers work reactively, patching here, debugging there. GitHub Copilot's agent mode aims to hold broader context and coordinate changes across files. In this video, we'll demonstrate how that workflow looks inside a real podcast NET and Azure project. We'll walk through a live solution and show before and after agent changes. You'll see how to generate multi-file code with less overhead, resolve cross-file errors faster, and even use a plain language spec to scaffold features. And before we get there, let's start with the hidden cost of the debugging loop so many of us live in every day. The hidden cost of patchwork debugging. You sit down to fix an error that looks simple enough. The application won't build, and the console flags a line in your main project file. You tweak the method, recompile, and think you've solved it, until the same message reappears in a slightly different form. Another half hour slips by before you spot the real issue, a missing dependency tucked away in another project folder. By the time the reference is corrected and you redeploy, most of your afternoon has dissolved into patchwork. The feature work you planned, it's pushed to tomorrow. This pattern is so common it feels normal. On the surface, you're moving forward because each bug you squash feels like a win. In practice, you're running in circles. The loop is code, compile, error, fix, repeat. Hours vanish into chasing a trail of cause and effect, and the net result is reactive progress rather than meaningful improvements. How many of you have lost an afternoon to this exact loop? Drop a one-line comment. I'll read through the top replies. What makes this cycle exhausting is that the tools around us keep advancing while the pattern doesn't. Editors add new features, frameworks evolve, and integrations grow deeper. But debugging still demands a reactionary approach. It's like trying to hold back a growing fire with a bucket of water. Each flare-up gets handled in the moment, but the underlying conditions that sparked it remain, almost guaranteeing the next blaze. And with every tap switch, the hidden cost rises. You move from a service class into a configuration file, then jump across to a dependency graph. Each shift pulls you out of whatever thread of logic you are holding, forcing a mental reset. It's not just the seconds spent flipping windows, it's the mental tax of reconstructing context again and again. Over a day, those small resets pile up into something heavy. For individual developers, the fatigue shows up as frustration and wasted time. For teams working on enterprise projects, the impact multiplies. Debugging loops drag sprint goals off track, delay feature launches, and open up a backlog that grows faster than it shrinks. The strengthening of technical debt is just another side effect of hours lost to firefighting. Many teams report that a large share of their development time gets siphoned into reactive debugging. It's not the exciting part of engineering. No one plans a roadmap around chasing the same dependency mismatch 5 times. Yet this is where bandwidth goes, week after week. When fixing errors becomes the definition of progress, building new features becomes secondary and the architecture suffers quietly in the background. The uncomfortable truth is that patchwork debugging doesn't just slow things down. It reinforces a culture of reaction instead of design. You're spending time dousing flames, not constructing systems. That may keep the product alive in the short term, but it limits how far a team can scale and how confidently they can ship. So let's pause on that image. Firefighting. Dash to the hotspot, dump water, move on. The trouble isn't that developers aren't good at it. They are. The trouble is that the flames never really stop. They just move around, flaring up in new files, new projects, new configurations, keeping everyone in response mode instead of creation mode. That raises the question, what happens if this cycle doesn't rest on you alone? What if the repetitive parts, the loop of tracing, switching, and patching, could be managed differently while you stayed focused on building? Because while the strain of firefighting is obvious, there's another pressure point we haven't touched yet. The real weight comes when your project isn't just one file or one module. It's when the fix you need spans multiple layers at once. Picture sitting down to open a solution where the logic sprawls across different projects, services, and libraries. The part you need lives in 3 places at once, and keeping it straight in your head is its own battle. Multifile chaos versus AI context control. When projects span multiple layers, the real challenge isn't writing code, it's holding all the moving parts together. This is where the tension between multifile chaos and AI-driven context control shows up most clearly. Take a large net solution with a dozen or more projects. Any new feature usually touches different layers at once. A controller in one place, a service in another, and a set of configuration files that live elsewhere. Before you write a single line, you spend time tracing references and checking dependencies, hoping a small change doesn't ripple into unexpected breaks further down the chain. That workflow isn't an exception. It's normal in enterprise applications, especially once Azure services and integrations enter the picture. The structure of these systems isn't flat. Interfaces, dependency injection mappings, and cross-project references all play a role. With Azure in the mix, some dependencies step completely outside the solution folder: function apps, service bus bindings, resource settings, storage connections. You're coordinating between code in your IDE, config files on disk, and services defined in the cloud. None of them care that you'd like fewer clicks. Every time you switch context, you burn energy reconstructing the bigger picture. Most of us try to juggle that context in working memory. At first, it's manageable, but as the project grows, mistakes slip in. You add a new method in a service, but forget its DI registration. You code up an Azure function and only later realize the binding never got added to host, JSON, or the deployment template. Nothing alerts you until runtime when you're debugging instead of building. The code itself isn't the hard part, it's the cross-file coordination. Everyone knows the feeling of bouncing through tabs. From a controller into a service, then over to a model, then into configuration files, then back again, only to lose track of why you opened that file at all. It's a small disruption repeated dozens of times a day. Those interruptions pile up, creating friction that drags down real progress. The result is slower delivery, not because writing is slow, but because keeping everything in sync steals focus. This overhead grows in cloud-first projects. Azure pushes key settings into multiple places. Local config files, environment variables, ARM or bicep templates, CI/CD pipelines. What looks like a single feature request often spreads across 4 layers of abstraction. The complexity isn't optional, it's built into the way the ecosystem works. Now here's where agent mode enters as a potential shift. Instead of leaving all that orchestration to you, it's designed to hold broader context across multiple files. That means when you ask for a change in one layer, it doesn't ignore the others. In the demo, I'll create a new Azure function and show how the agent helps by generating the method body, producing the binding config, updating host, JSON, and even suggesting the right DI registration. That's usually a multi-step process scattered across different files. An agent can streamline it into one flow. This is not about replacing your judgment. It's about removing the repetitive bookkeeping so you can focus on the actual design choices. Humans can keep a rough outline in their heads or sketched on a whiteboard. An AI can track the details file by file without losing the thread. What feels like a huge cognitive load for us is just baseline context for the agent. The difference in practice is moving from fractured tab juggling to orchestrated changes that stay in sync. I'll also pull up the agent-created pull request or diff during the demo so you can see exactly what edits were made. That visibility matters. You get full control to review and approve, while the legwork of updating multiple files happens for you. So instead of spending an afternoon stitching fragments together, you direct the change once, confirm the generated updates, and move on to higher level design. The relief isn't just in saved clicks or keystrokes, it's in staying focused on solving actual problems rather than retracing how a dozen files connect. This advantage shows most clearly when things break, because even with stronger context handling, systems fail, configs drift, and mismatched references creep back in. And that's where the next test begins, how errors get tracked down and resolved once they surface. From error hunts to autonomous fixes. Think about how often you hit an error message that points straight at a single file. You follow the stack trace to the method it names, make a small adjustment, and hit rebuild. It feels like the obvious solution until the same error appears again, just in a slightly different form. That's when you realize the stack trace only showed the symptom. The real issue lives somewhere else entirely, maybe in a supporting class or hidden inside a config file you haven't opened all week. Every developer has faced that kind of misdirection. What looks like the problem isn't actually where the fix belongs. This eats up time fast. You adjust one thing, rebuild, wait. Then a fresh error greets you, leading to another file, another tweak, and another rebuild. The loop looks productive because you're moving, typing, recompiling, but under the surface it's trial and error more than actual resolution. That cycle can swallow hours, leaving you with tiny surface fixes but no real forward progress on the feature you started with. The real cost here is opportunity. While you're caught in the rebuild and retry rhythm, you're not solving business problems or shipping the functionality your users are waiting on. Momentum goes into guesswork instead of design. It feels active in the moment, but those hours don't add up to much beyond keeping the system from being broken. Across a team, this shallow motion slows everything down and creates a backlog of features that keep sliding forward. Here's where an agent workflow begins to look different. The idea isn't stopping at the one line your stack trace highlights. Instead, it's designed to hold system-level context, asking not just what should this file do, but what sequence of changes is needed across connected pieces to restore consistency. In practice, that means you may see it propose edits that span multiple files. For example, you'll see in the demo that when a method requires changes, it can suggest matching edits in related configs or deployment templates, instead of leaving you to hunt them down. That's the jump from autocomplete to something broader. Autocomplete finishes lines, an agent coordinates across files, and that coordination matters most when errors don't live neatly in one place. Take a common Azure scenario. You build a new function app, but once deployed, the queue trigger fails because the binding doesn't match the method signature. Normally, you dig through logs, figure out which binding is off, adjust the function, JSON by hand, maybe even alter your infrastructure template if a value is mismatched there too. Every step is a separate chase, and every fix triggers another test run. With agent mode, the workflow is different. It can propose the code change, generate the proper function, JSON binding, and surface edits for deployment scripts if they're misaligned. You review, confirm, and move forward without spending hours piecing each layer together. And trust is the key here. Nobody should feel like invisible edits are happening in the background. That's why the review flow matters. In this demo, we'll walk through it together. The agent suggests the coordinated changes. We'll open the diff to inspect exactly what it generated, run our unit tests, validate the build locally, and only then choose whether to accept or reject the edits. That validation loop keeps you in full control while removing the grunt work. It's worth stressing. Agents can help move faster, but they don't replace good engineering practices. You should still treat code reviews and CI as non-negotiable gatekeepers. Let the AI reduce the time you spend on detective work, but keep automated checks and human review as the safety net. That balance solves the trust problem and ensures the speed gain doesn't undermine stability. The speed difference is not theoretical. Where error chasing and manual patching may chew up half a day, coordinated suggestions can narrow it to minutes. And the reclaimed time flows back into the work you actually want to spend energy on. The features your users notice, the architecture decisions that improve your code base. Instead of firefighting at runtime, you get to design with confidence upfront, so the debugging loop no longer has to define your day. With an agent suggesting cross-file updates, you shift from scattershot searching to a review and approve rhythm. You stop wandering through errors in circles and start treating debugging as a structured, almost automated step in your workflow. That shift frees up cognitive space and calendar hours for building features, not just patching flaws. And once fixing errors becomes less about chasing symptoms, it opens the door to something bigger, how you might start whole features in the same structured way. Imagine if the same workflow that proposes coordinated fixes could also take a plain language specification and shape a working structure around it. That's where the next stage of development begins. Spec-driven development without the overhead. One of the most interesting shifts comes when you stop thinking only in terms of files and methods and start framing work in plain language instead. That's where spec-driven development without the overhead comes in. Picture writing out a simple feature request. Add a reporting workflow that generates monthly summaries, stores them, and makes them available through an admin page. Instead of just getting a few isolated snippets, you return with a working structure already mapped across your app. Controllers stubbed in, models created, services registered, and configuration wired. That move from describing intent to seeing a concrete scaffold appear in your project is where this approach finally feels practical instead of theoretical. In traditional setups, spec-first development has a heavy reputation. In large organizations, it usually means long requirement docs, multi-page design sheets, and rigid diagrams that slow everyone down. They make sense in regulated industries or globally distributed teams, but for everyday coding, most developers skip them. Writing and maintaining detailed specs adds cost nobody has the patience or time for. It's extra work stacked on top of shipping features, and as deadlines press closer, those extra cycles are usually sacrificed. The irony is clear. Developers actually like thinking in broader strokes. Knowing the structure ahead of time is reassuring. The problem isn't the intention, it's the upkeep. Once the spec starts slipping out of sync with reality, the maintenance becomes a burden. That's why so much of real-life work drifts toward improvisation rather than complete design, even in shops that technically endorse heavy planning. An agent workflow offers an alternative. Instead of demanding a polished design doc, it can help translate a plain language spec into a scaffold you can refine. You don't need UML diagrams or handwritten interface maps. You can simply say, create a reporting module with a new API endpoint, link it to storage, and secure it with role-based access, and the system generates a baseline across files in your NET solution. In the demo, I'll read a plain language spec aloud, then show the files the agent produced, controllers, models, and service registration, and point out the spots that still needed manual refinement. That way you can judge the quality for yourself. This sets up a middle ground between two developer modes. On one side, there's vibe coding, fast, freeform, but fragile for long-term systems. On the other side, there's spec-driven design, reliable, but painfully slow. With agent support, you outline the idea in natural words, the scaffold shows up, and you can iterate almost as quickly as vibe coding while keeping the benefit of an organized structure. Take that reporting workflow again. Usually you'd have to create the model, build the data service, wire up the controller, configure security, and connect everything in startup. That means bouncing through multiple files and hoping consistency holds. With this approach, the scaffolding lands in place at once. The real savings come less from typing fewer lines and more from avoiding cross-file slips, like forgetting to register a new service after you've already built it. Of course, there's always the question of style. Will an AI force boilerplate or override conventions? In practice, agents often mirror existing project patterns in their suggestions. In the demo, you'll see both sides. Places where it matched our repo's controller structure perfectly, and places where its guesses slipped out of alignment. That mix is important. You'll know what you can trust and what you still need to adjust. The end result isn't cookie-cutter code. It still feels like your project, only with less manual scaffolding work. You get to keep speed and still rely on a foundation that you can refine for future growth. Instead of spec work being limited to architects with the patience for diagrams, it becomes a tool for any developer who wants to experiment quickly without sacrificing order. And when this becomes part of your daily flow, specification stops feeling like a formal enterprise step and more like a lightweight shorthand. You describe your intent, the system lays the groundwork, and you focus on shaping the details. The bigger impact comes not just from the code you generate, but from what the time savings mean week after week. More hours for features, less grind in setup. That brings us directly to the question every developer cares about most: what these changes actually add up to in terms of productivity. The productivity payoff. The real question is not whether you save a few minutes here and there, but how those small shifts accumulate into meaningful hours across a week. This is the productivity payoff, regaining time that usually slips unnoticed through context switching, repeated build cycles, and manual patching. Most developers accept those small losses as just part of the work. 10 minutes here chasing a config value, another 15 rerunning after a missed reference, or bouncing between files to check connections. On their own, they feel minor. But added together across a full sprint, they shape how much actual value gets delivered. What looks like routine motion hides a real drag on delivery timelines. The hidden weight isn't in compile times or typing speed, it's in the stop-start rhythm imposed on your concentration. Every time you move from one file to another, your brain resets. That reset has a cost. Offloading repetitive corrections to an agent lightens that burden. Instead of constantly reconstructing context, you spend focus where it matters, solving the bigger design problems. Many teams don't track these micro costs because they don't appear in Jira tickets or Git history. Work that goes nowhere isn't logged, but it still consumes energy. And as code bases scale, this friction doesn't just add linearly. More layers mean more dependencies to hold in memory and more chances to lose time simply aligning structure before progress can continue. Agent workflows change the math by targeting these drains directly. They don't just fill method stubs quicker, they reduce the loops of searching, patching, and rerunning that eat afternoons. Teams using agent workflows report shorter time to unblock in many cases. In this video, we'll demonstrate one before-after task so you can judge the impact. I'll record the time it takes to implement the same Azure feature manually and then again with the agent so you can see the productivity gain in concrete terms. From a business lens, the value shows up in project velocity. Faster cycles aren't only about developer satisfaction. They decide whether features ship in this release or slip quarters forward. They influence technical debt since fewer hacks and regressions lean into the backlog. A smoother flow lets teams move ahead cleanly instead of revisiting broken work from the sprint before. That consistency compounds into less firefighting and stronger delivery over time. There's also the human factor. A day lost to error chasing leaves any engineer drained. Once you're fatigued, clean design work gets harder, detail slips, and mistakes creep in. By shifting mechanical fixes to an agent, developers stay alert for longer stretches. That extra focus sharpens both productivity and quality. When you're not grounded down by repeated friction, you're free to think broadly and plan more effectively. The difference in practice looks like this. A new Azure function with multiple bindings and service integrations might stretch into 2 full days unaided. Between configuration, testing, and backtracking from mismatched references, the task drags on. With an agent helping, the same function can emerge in half a day. Not because corners get cut, but because the cross-file setup and orchestration land consistently the first time. The timeline shrinks by removing false starts and redundant effort. Some developers voice a fair concern. Does relying on an AI to handle maintenance dull your own skills? The perspective often misses what's really shifting. Offloading repetitive setup doesn't weaken your expertise, it preserves it for design and architecture, where judgment creates leverage. In reality, you gain room to practice higher-order problem-solving instead of wasting energy on rote corrections. If you try this out, comment with how many hours you've reclaimed in a sprint. I'll pull interesting responses into future videos. Hearing how other teams experience the shift gives everyone a better picture of the real value, beyond demos and examples. A note of caution though, automation helps, but safety still matters. Always run your tests and use code review to validate agent-created changes. Trust that the busy work gets reduced, but keep the same guardrails in place. The speed difference only pays off if the quality holds steady. Strong tests and smart PR review protect your release pipeline from fragile automation. The payoff is less about cranking out lines of code quickly and more about freeing space to produce stronger solutions. With less fatigue and fewer distractions, teams move past patching to actual building. That shift opens the door to a broader mindset, where projects are less about reacting to fires and more about shaping clear, organized systems from the start. And that brings us to an even larger point. When you stop spending your energy in piecemeal loops, the nature of building software begins to look very different. Coding workflows don't have to stay reactive. The point of this walkthrough was to show how agent support changes where your time goes. You move from firefighting to building features with fewer interruptions while still keeping full control over what ships. Here are the 3 takeaways. 1. Agent workflows reduce cross-file friction. 2. You can use plain language specs to scaffold features. And 3. Always review diffs and run CI before merging. Try Copilot's agent flow on a real problem this week. Pick the task that usually eats an afternoon, time it, and compare. Drop the outcome in the comments. The agent suggests changes. You still review, test, and decide what to merge. If you found this useful, like and subscribe for more hands-on AI plus Azure tooling walkthroughs.